See, that's our x-axis. And the object is moving on this x-axis in this direction. So I start observing so this is my suppose origin, and I start observing the position of the object at this point. So t is equals to 0 here. So that's t equals to 0. So this position is x1. And I observe it up to time t, and this position is x2. So velocity here was suppose v1 at this point of time, and velocity here is at t2. I can write this v1 as v0 also at 0, and I can write this as u also. Similarly, x1, I can write it as x0 also. Okay. Now, what is, if I talk about average velocity? So average velocity is your displacement upon time taken. Now this displacement is final position minus initial position divided by delta t. Now there can be two possibilities. Your velocity is negative or positive. See, delta t is, it will always be positive, t2 minus t1. So this quantity will always positive because t2 is always greater than t1. Now what about this quantity? If I'm moving in this direction, so that's my positive direction. So this x1, this is your x2. So you are moving from here to here. So that's your final position. So change means final minus initial. So your final is x2 minus x1. So this number will obviously be positive. So you'll get a positive displacement. But if suppose now you are moving in this direction from, so this was your point A to B, and these are some other points. So you are moving from C to D. So in this scenario, this will be your x1 and this will be your x2. And this direction is positive direction. So obviously, and this is where your origin is, so obviously in this case, you can see that x2 minus x1, which is your displacement, this displacement will be negative here. So why it is negative? Because see, suppose this is let me mark x2 equals to 2 meters and x1 is equals to 4 meters. So obviously x2 is lesser than x1. So we'll get here final position 2 meters minus 4 meters, that's minus 2 meters. Here suppose it was 3 meters and here it is suppose 6 meters. So your answer was 6 meters minus 3 meters plus 3 meters. So we are discussing about this displacement. So displacement is negative in this case and positive in this case. Means if you are moving in the direction of, in the positive direction, so that's your positive displacement. Moving in the negative direction, displacement will be negative. So this sign is clearly telling you the direction. And this is clearly telling you the magnitude of displacement. Right? So here also direction and this magnitude. Now, what about the average velocity? So here the time taken is 2 seconds, and here also the time taken is 2 seconds. So your average velocity will be plus 3 by 2 meter per second. And here your average velocity in this case will be equals to minus 2 by 2, that is equals to, so it is plus 1.5 meter. 1 meter per second. Oh, sorry, not square, it's meter per second. Good. And here it is minus 1 meter per second. Absolutely right. So the point here is that here I am getting this positive velocity, and here I am getting this average velocity as negative. So why I am getting, see what this information is telling me. See, this positive is telling you the direction, because this positive, you get this positive here due to the direction of displacement. And what the displacement is telling you? Displacement is telling you the direction. So this plus comes from here. So this plus actually comes from displacement, right? So this plus comes from displacement. So the direction of displacement is the direction of velocity. So therefore, direction of displacement is same, or it's better to write direction of velocity is same as direction of displacement. So you find the direction of displacement, and direction of displacement depends on, if you are moving in positive direction, it's positive. If you are moving in negative direction, it's negative. So that's from where we get the direction of displacement. So that's absolutely fine. Now comes the acceleration. See, we have two cases, like here, the velocity v1, when I start observing at time t1, the velocity was 4 meter per second, and here the velocity becomes 10 meter per second, that is v2. And obviously in this direction, so both the velocities are positive. In the positive direction, that comes from displacement, because displacement is positive, this is x1, this is x2. So displacement is positive, so the velocity is also positive. Now, I am taking another case. So in the same direction, I have v1, this is 4 meter per second. And it might be possible that here the velocity becomes 2 meter per second. That can also be the case. So here I am accelerating, yes. Here my force is in this direction. But here my force is in this direction. Yes, I am applied the brakes here. So I have applied the brakes, and here I am accelerating. Is this clear?
Yes, sir.
So now the important thing is that when I am finding the average acceleration, that is equals to dv by delta v by delta t, and that is equals to v2 minus v1 upon t2 minus t1. So this t2 minus t1 always positive, as I told you, because t2 will always be greater than t1, because this is a final time, this is the initial time. Now the sign of your average acceleration depends on change in velocity. Yes. So this, what I am getting here. So in case of displacement and then velocity, displacement was depending on the here your displacement. So velocity was depending on displacement. So whatever be the whatever happening with displacement, same with the velocity. And displacement happening depends on the x2 minus x1. So in positive direction, x2 was increasing. But here in this direction, there can be two things. You are moving forward, means you are moving in positive direction in both the cases. But in one case, velocity is increasing, and in another case, velocity is decreasing. So if this is the first case and this is the second case. So in first case, suppose the time taken in both the cases is 2 seconds. So 2 seconds is the time taken. Now change in velocity v2 minus v1. So here it is, v2 is your 10 meter per second minus 4 meter per second divided by time is 2 seconds. So means the difference I am telling you is the 2 seconds. So here the acceleration comes out to be 6 meters upon 2 seconds. So 6 meter per second upon 2 seconds. That's the change in velocity. So velocity changes to 10 from 4. And that's plus 3 meter per second square. So that was the average acceleration in first case. What is the average acceleration in second case? In second case, it is 2 minus 4. So final velocity is now lesser. So that's the point. Divided by 2 seconds. So that's minus 2 meter per second divided by 2 seconds. And that is equals to minus 1 meter per second square. So here the velocity was depending on plus means x2 was greater than x1. And here x1 in this case, the delta x, that is x2 minus x1. So here x1 was greater. Okay. Here x2 minus x1. So here x1 was greater. Now here in this case, you get negative, you get positive because final velocity is greater than initial velocity. You get negative because final velocity is lesser than initial velocity. So that's the, it is a vector quantity, it is also a vector quantity. But see here, what is the interpretation of positive and negative? Positive and negative interpretation means this is positive and negative. They are telling you the direction of the motion here. Okay. So direction of motion. So motion means velocity. So direction of velocity, direction of motion depends on in which direction you are moving. So direction of motion means direction of velocity. So simply in which direction you are moving. If you are moving in positive direction, so direction of velocity is positive. If you are moving in negative direction, direction of velocity will be. So here you are moving in negative. But in case of acceleration, as the acceleration depends on final velocity minus initial velocity. So if final velocity is positive, means is greater than acceleration. So it means this sign, what is the interpretation of this sign? So this sign tells you whether the velocity is increasing or decreasing. Okay. So of course here also it is telling you whether the displacement is increasing or displacement means the final position is it more or less? But yes. Now here we can clearly tell that the sign tells you, in case of acceleration, sign tells about whether the velocity is increasing or decreasing. So I hope you have understood this discussion. Now, if you look at the other way of it, so F is equals to ma. So force is equal to mass into acceleration, and acceleration depends on the force. So the direction in which you have the force, in the same direction you will have the acceleration. So that's the net force, always. So if acceleration is, now you can come at the directions. If you want, sir, I want this direction, so I want to understand it in terms of direction. So this direction is the direction of force. That's the direction of force. So that's the direction of force, not the direction of motion, but direction of force. So if force, so direction is positive. So here velocity is positive and direction of force is also positive. So force is also positive and you are moving in positive direction and greater force. So obviously your velocity will increase. Now you are moving in positive direction. So velocity is positive, but force is in opposite direction. You have applied the brakes. So acceleration will be negative. So because so the direction of acceleration is the direction of force. And direction of velocity is your direction of displacement. So that thing you need to understand. Okay, so very important discussion what these signs are telling you. Okay, now let me see who is present in the class. So we have two bright students. So what shall I discuss with you to you tell your individual problems? Which topic? So this was one of the topic of discussion that I have just taken with you. Other than that, see, this class was aiming for the students, like I taught them average velocity and instantaneous velocity concept yesterday. So today I was supposed to take the numericals based on it. So, but the students are unfortunately not present in the class. So what shall I do? So shall I take the numericals that I have planned for 2-3 simple numerical based on this, but they will be, I know they will be quite easy for you people. So sort of revision for you, or if you want to take any other topic that you would like to discuss, you can tell me, because that's individual one-to-one class. So, and anything special, any doubt that you would like to discuss, or anything, you can tell me.
Sir, numericals.
Numericals, okay. So I'm giving you numerical. You have a question? So we have displacement, which is a function of time, and it is given as 18t plus 5t square. Now, so average velocity we have discussed. So average velocity means simple displacement upon time. Now what about simple velocity? Means the instantaneous velocity, velocity at an instant. So there I take the displacement as very small and take the time as very small. Now it will be very difficult to, if the time is very small, like so many, see, take the time as small as possible. Okay, so like this is 0.00001 second or even smaller than this, and your displacement comes out to be, or let that, you will better understand, let the displacement will be 0.00023 5 meters, and the time is your 0.0000326 seconds, suppose. So it's very difficult to do these tedious calculations. So instead of finding the instantaneous velocity this way, we have another way to find the instantaneous velocity. So for that, instead of writing the value of displacement, I write this, I treat this x separately. So I will treat it, this x, separately. So, and this will be my operator. So this is how to find. So meaning we have understood, but how to find this dx by dt? So that's a different method. Okay, so by dividing we cannot find. So what is the method for that, to find this out? So for that we need to separate them. So this is d by dt, this is this is operator, differential operator, and this is x. So this x we have to write as function of t. In terms of t, I have to write the x. So let me write this x. So that will be given to me. So x in terms of t. So see, this is x, but in terms of t. Okay. So I will get, yes. So what do I get here? So that's velocity. So I get velocity here as, so Naman, you can tell me what is differentiation of 18t?
Sir, 10t
Okay,
plus 18.
very good, absolutely correct. So the point here is that when we are using this differentiation, we are getting functions. Okay, so here we were dealing with constant values, okay, in these formulas. But here, when we are using this differentiation to find the instantaneous change, we use functions like velocity, that's also in terms of t, displacement, that's also in terms of t. See, we have already studied function. See, polynomial function p of x, that's equals to x square plus 3x plus 7. So that's another polynomial function. So that's a polynomial. So it can be x cube plus 4x square plus 3x plus 1. So it means this polynomial p, its value depends on x in this way. So these are the functions. You are getting the functions. So when we are dealing with this calculus, actually, we are dealing with functions and not with constant values. So if we get a constant, if we want to do the constant derivative of a constant, that will be 0. So here we are dealing with the functions. Okay, so that's the difference between average and instantaneous. So in average we deal with constant numbers, but in average, as the numbers are getting very small, and it's not, and still I don't get the accurate answer, because I want this time to be more smaller, more smaller, to get the, so displacement will also be very small. So both will be getting very small, and still I will not get the correct answer. I will be very near, because why will I not get the correct answer? Because I am using the way of average velocity. Concept to learn, I have taken this as very small dx, very small dt, but it's not possible to calculate it like this. So I use differentiation process concept. Okay, got it? Now my question is, you have to calculate the instantaneous velocity. So I write it simply a. So instantaneous velocity at t is equals to 2 seconds. And
38 meter per second.
Okay, very good. Absolutely correct. So again, instantaneous acceleration will be dv by dt. So that's so I differentiate 18 differentiate 0 and 20 is 10. So that's acceleration is constant. So it does not depend on t. So at any point of time, whether time is 2 seconds, 3 seconds, 4 seconds, any time you have the constant velocity, constant acceleration, sorry. Now, what is instantaneous velocity at 2 seconds? So, what is the velocity at 2 seconds? That is instantaneous velocity at 2 seconds. Yes. Simply put t equals to 2 here in the velocity. Yes. What do you get? 10 into 2 plus 18. Yes, Naman.
Sir, 38 meter per second.
38 meter per second. Absolutely. So, third is what is the position at time? 2 seconds. Yes. See, that's 5 into 2 square plus 18 into 2. That's 5 for the 20 plus 36. So that's equals to 56 meters, right?
Yes, sir.
So fourth question. So only four questions can basically be framed. So acceleration at any point of time, velocity at any point of time, and this position at any point of time. And the next question that can be framed is of average velocity, because constant means average acceleration is same as your instantaneous acceleration. So no question can be framed from there. So only question left is your average velocity, because instantaneous we have taken. So average velocity now between which time to which time? So average velocity you have to tell between 2 seconds and 3 seconds. So tell me what's the average velocity between 2 seconds and 3 seconds. So obviously average velocity is your displacement upon time taken, and displacement is your position, final position. So final position was at 3 seconds minus position at 2 seconds divided by delta t. Time is 3 minus 2 seconds. Yes. So position at, so same process now, position at 2, position at 3. So what's the position at 3? So 5 into 3 square plus 18 into 3 minus position at 2 second. So that's you have already calculated. So position at 2 seconds, and this divided by time, that is 1 second. So what you can do here is you can clearly see this will cancel out, and this is 5 into, so 5 you can take out, and don't do the mistake, this is 9 minus 4. So 9 minus 4 is again 5, or you can write 3 plus 2 and 3 minus 2. So 3 minus 2 will be 1, and 3 plus 2 will be this, right? So you have 5 into 5, that is 25 meter per second. So you can see the velocity at 2 second is 38 meter per second, and velocity at 3 it should be greater. So this answer is supposed to be, see what we are doing here. So velocity, yes, okay. So at 3 seconds, the definitely the velocity will be 30 into 18. So this answer should be more actually. Yes. So what we have done?
So that would be 3 squared plus 2 squared.
Sorry. 3 square minus 2 square is 5, right? 5 I have taken common.
Sir, but answer was that 25 meter per second.
See, the instantaneous velocity is 38 meter per second. How
Sir,
can be the average velocity? And what is the velocity at even 3
सर
seconds?
आपने एक मिस्टेक कर दी.
Yes.
18 वहां पे सर 2 आएगा.
Oh, absolutely. Thank you so much. Thank you, Naman. You are absolutely a super boy. Okay. So yes, that's the mistake. So I have to add now this thing. So I have to add 18 now because 3 minus 2 is so 18 to it. Add 18 to it. And that will I get 43 meter per second. Yes, that's correct. So at 2 second velocity was 38 and at 3 second, what's the velocity? 10 into 3 plus 18, that is equals to 48 meter per second. Absolutely. So here students, as the acceleration is constant, so you have another formula for the velocity. Acceleration is constant. So you can take the velocity as arithmetic average. So 38 plus 48 divided by 2. And that's again 43 meter per second. So you can take the arithmetic average, initial and final velocity. Okay. So I hope so only these questions can be framed. Okay. So only these kind of question that can be taken. Is it okay, students? Good. Done.
Yes, sir.
Okay. Now let us do one more type of question. That is acceleration is given to you now. The function of acceleration is given to you. Okay. And particle starts with velocity. So that's v1, that is 2 meter per second is given to you at time t is equals to 0. Find the velocity at the end of 2 seconds. So what is v2? That's you have to find. So students, I told you that whenever you are dealing with these averages, okay, so you will be dealing with constant numbers. But whenever you are dealing with instantaneous quantities, so there we are dealing with functions. So here we are dealing with constants. So there are constants here, this displacement, velocity. But here when we are dealing with this, there are functions. So actually this is a function of displacement. And what function is it? What do you get here? You get a slope function. Okay. So you get slope function here. So that's function and that's slope function. Slope of x. That's x function. Position function. And d by dt. Dx by dt is the velocity that you are getting. That is slope of this graph, means when you will be drawing this graph x versus t. So like suppose this was your x t and its graph will be something like here it is decreasing, so the graph is decreasing, slope is decreasing, and then the slope is so negative slope and positive slope. So how will you draw the graph? Slope is negative in this point to this point, slope is negative, yes, and here the slope is 0. So that's velocity. So the slope is 0 at this point, and before that it is negative. So and after that it is positive. So that's the slope. And if this function is suppose x square, this dx is t square your function, so then this slope will be 2t. So differentiation of, so that's the slope function and that's the function. So if we differentiate, we get the slope function. So that's the main point. Now what about its opposite? From here to here. So this area, this total area will tell me the see v is equals to dx by dt. So area dv by dt. So the area under this graph will actually tells you the displacement, isn't it? Yes. Now again I am taking this when I will be dealing with only variables, like in this case. So I treat them separately, like dx separate, dt separate. Okay. So I've taken this v. So just like your average velocity is equals to change in displacement upon change in time. And what will be your displacement? So displacement will be equals to average velocity into time. Right? So same is the formula here. So as your displacement is equals to change in velocity into time, means average velocity into time. So that's the total time taken, of course. So here the same formula will become this as this will become instantaneous, and this is dt. Again, we cannot find it like we find here in terms of constants. Here again we will be dealing with functions. So x as a function of t and velocity also as function of t. Okay, so both of them are function of t. So we need to keep on adding this small dx and we get the total displacement. And here also, so integrating both sides, we get. So here differentiating, here integrating. So when I need to add small dx, yes. I hope this is clear to you. Yes. This important discussion. So the formula you have v is equals to dx by dt. So the point here is what you need to find. If you need to find velocity, good enough. X is given to you, very good. So v is equals to, put the value of x here. Means this x as function of t, definitely t square plus 2t might be like this. So simply put t square plus 2t, do the differentiation of it, and it's over. Now suppose you have to find displacement and velocity is given to you. Suppose it can be t plus 2, let it be like this. Now what will you do? How will you use this? Now you have to find x. So whatever you have to find, bring it this side. So dx this side. So this here, this thing, so write it this way. This thing, write it this way, right? Okay, now dx is equals to, take this dt this side. So I told you this v equals to dx by dt. We get it from, this is the origin of it. And when time is very small, limiting delta t tends to 0, we get this. So this is simply very small displacement, very small time. So it depends on us if x means we deal with them. If constants are given, we'll be dealing with this formula, but if functions are given of x and v, we will be using them. So you can use them as two ways. First way is dx divided by dt, and second way is d by dt. So assuming this as operator and then this function. So when this, you will use it this way. So differentiating. So d by dt is your operator. So here dx by, so that's your choice. So here what you will be using it as? Dx divided by dt? Yes. this way. Okay, so what will be dx? Dx is this, there, simply dv, so dt will go that side, so v into dt. Got it?
Yes, sir. Yes,
So,
sir.
so whatever you have to find, bring it this side. Now you have brought it this side. First, this is the first thing you need to do. Now the second thing, if this is the whole velocity you have and this is what you need to find, okay, simply do the derivation. But here you are not supposed to find dx, you are supposed to find x. So you need to add all these small infinite dx. So these x are how many? They are infinite. So if they are finite, then we can use the symbol of summation also. But infinitely we need to add, so that's the symbol for long s, adding infinite dx, small dx. So adding small displacement, I will get the total displacement, isn't it? So this is suppose a total displacement. So I will be adding on this small in small time, because velocity was varying. So in small time, what's the distance traveled by particular velocity? Again, what is the distance traveled by the particular velocity? Again, what is the distance traveled? Because the velocity is changing. You can see that velocity depends on t. Because velocity is changing, so velocity is constant, I can simply take average velocity into time. But here the velocity is changing. That is why I need to calculate small displacements. Okay? So differentiating both sides. So that's the difference when you have to use differentiation. So students keep on asking this doubt, sir, when do we come to know that we have to use differentiation or integration? I hope this discussion clears it. Yes?
Yes, sir. Yes, sir.
Now when you are doing the differentiation, so you must know the formula of differentiation. If this is t raised to the power, if you are differentiating it, so then you will get nt n minus 1. And if you are integrating this tn dt, you will be getting t raised to n plus 1. Right? So that's the means formulas. Of course they are derived, but you need not to do the derivation. You need not to understand the derivation. Simply know that these are the formulas. Okay, so shall we do a question now based on this? So the question is, so question I gave you, acceleration is 3t square plus 2t plus 2, and if the particle, I told you that the particle at t is equals to 0, its velocity, it starts with the velocity of 2 meters per second, and final velocity you have to calculate in time 2 seconds. So at the end of 2 seconds. So of course this is instantaneous. I told you that in all these formulas, all the velocities that you are means they are instantaneous. Okay, all these are instantaneous, right? So what you have to find? You have to find velocity. That's good. So velocity and acceleration. So what is that? See, this is instantaneous. This is also function. So function, instantaneous, you know calculus. So write the formula for the calculus. Write the formula for the very small time. So what is the formula between a and v? Tell me. What is the formula for a and v? So a is equals to rate of change of velocity dv by dt, right? So what you have to find? You have to find, my dear, velocity. So write the velocity, bring velocity here. So velocity is equals to a d by dt. So that's the first step that you have done. So first step is the relation between what is given to you and what you have to find, and this is the step 2. What you have to find, bring it here. Now you have to find, this is telling you the small change in velocity in small time, but you have to find all these small changing keep on adding to this velocity. Velocity is increasing and keep on increasing this small velocities, and how much velocity it will be. So you have to, this is the third step now, integrating it. And from where to where? So velocity from v1 to v2, and this is 2 is given to you, let it assume as x. So 2 to x. And what was the time? So here this is change in time, here velocity. So what was the time when it was 2? So time was 0, and here the time is 2 seconds. So it's as simple as that, students, right? Come on, you can calculate it. So
Sir, for t0 acceleration is 2 meter per second square and t is 2 second acceleration is 18 meter per second square.
okay, acceleration, okay, acceleration is changing at every point. It depends on t. So here the acceleration is different, here the acceleration is different. Okay, but you are only supposed to find what is the velocity at that point. So you have found the velocity and instantaneous acceleration both. That's okay. That's okay. That's good. No issues. You can find the okay. So students, what's here? What do we get? So, or you can write the final velocity as v also. Let the final velocity as, instead of x, let us take it v, because x might confuse us. Let's take v. So what is the integration of dv? That's v, and then taking the limits from 2 to v, and put the value of this a here. So a, which is, so I can write it a, I can write it a as function of t, that's the same thing. So what's the value of a here? So 3t square plus 2t plus 2 integration 0 to 2. Okay. Now this limit, so put final limit v is equals to v minus initial limit 2 is equals to final limits, put t is equals to, so first of all we have to integrate it. Okay, so integration of 3t square, so 3, and then integration of t square is plus 1, so power plus 1 divided by 3, then 2 into 2 constant will come outside, 2 raised to power 1, so 1 plus 1 is 2, and divided by the same power, plus integration of 2 is 2t, so 0 to 2. So what do you get here, students? Velocity minus 2 is equals to, so this 3 cancels out, 2 also cancels out. So now put here t is equals to 2, so that's 2 cube plus 2 square plus 2 into 2 minus, put t equals to 0, so that's 0 cube plus 0 square plus 2 into 0, so that will be 0. So you get v minus 2, let's calculate it, 8 and 4 and 4, so 8 plus 4 plus 4, that is 16. So your velocity comes out to be 18 meter per second. So that's your velocity is at 2 seconds. Okay, and acceleration at 2, at this point of time. So but so acceleration actually it will be means like t is equals to 0, t is equals to 2 seconds. So what's acceleration over here? You can find from this formula. But see here, there's one thing. If you want to use this formula for acceleration, actually you have to assume the acceleration here as 0. So you have to assume that it is coming with 2 meter per second constant velocity till here, and from here the object starts accelerating. Yes, this is what you need to assume if you are finding acceleration from this. Okay, students, and there is like you say, sir, I'm getting a particular velocity, but I'm not interested in particular. I'm not interested in definite velocity. I am interested. What I'm interested in? I'm interested in. I want to know the function of instantaneous velocity. So indefinite. So wherever I want to find values of velocity, I can find. So from here, I can find only one value, sir. Okay, so you want to deal with indefinite integral. So for that, don't put the limits then. So it will be dv is equals to 3t square plus 2t plus 2 into dt. So this is indefinite integral, students. What's the difference? Let us see. So this change in velocity, as I told you, keep on adding this. So that's v. Now integration of this, that will also be same. So that's the same. Means t you will get this cancels out, and this is t cube plus t square plus 2t. That's same. But what's the point here is that you will get constant of integration. That is the difference. So you will get here constant of integration if you are dealing with indefinite integrals. So indefinite integrals, here it was definite integral. So you were definite that only at one particular point I want the velocity, but here indefinite means at any point I want to find the velocity. So you have to write here constant of integration, that is a constant. So now how to find this value of means constant of integration? So you know that you know at a particular time you must know the velocity for that then only you can find out. So we know that at t is equals to 0, v is equals to 2. So v is equals to 2 at t is equals to 0. So put the value of v and t, and you get this constant, and that constant is here 2. Okay, yes. So c is equals to 2. Is it okay or not?
Okay, sir.
So now you have got the constant of integration at 2. Now you get the function. So write your function. This was your function, but the only problem was there was constant of integration. So now you can write your function. So t cube plus t square plus 2t plus 2. So that's your velocity function. So you have acceleration function and you have velocity function. Okay. So now, so here also, students, actually at time t is equals to 0, I was little bit wrong. So at time t is equals to 0, put t is equals to 0 here. So at t is equals to 0, acceleration was 2 meter per second square already. It has considered it. So at any point now, at this point of time 2, you can put this, yes, you will get the acceleration at time 2. So put t is equals to 2. So 2 to 4 into 3, 12 plus 2 into 2, 12 plus 4. So 16 meter per second is the velocity, is the acceleration at time 2 seconds, because it has taken the effect of 0. So means yes. So I was telling you that consider acceleration is 0. No, because see here, the acceleration when time t is equals to 0, put t is equals to 0, you will get acceleration is equals to t. So acceleration was actually 2 meter per second square here also. Okay, and this acceleration is also changing. So when this acceleration is changing, you cannot use these formulas. These formulas are of no use. These formulas are of only use when a is constant. So you need to see here, students, that a is a function of t, so you cannot use these formulas, right? Is this clear? So here you have got the velocity function from indefinite integral, and from definite integral you are getting a definite value. So we want for velocity for time 3, so you have to write 3 here instead of 2. So you have to calculate it again for 3, but for here you have to simply put v at 3. You can simply write 3 cube plus 3 square plus 2. So that's the velocity at 3 seconds. Instantaneous velocity. And simply instantaneous velocity from here. So now students, you have also understood what the difference between definite and indefinite integral. So indefinite integral actually gives you a function, but yes, for that you have to find the constant of integration, right? So I hope today's class was quite fruitful for you people. Yes, was it fruitful or not, this class?
Yes, sir.
Yes, sir.